Right. Thank you, everyone, for joining the Internet of Value Foundation New York episode 143. And for all of those who come and listen to this information in the future, I hope you guys find it as valuable and enjoyable as I know I do every single day. The diverse amount of mindsets and perspectives that we get to have in here, and the great conversations that we get to have take place in these audio files, being something that I like to think of as factors of the stories of our time being able to be told, hopefully in a very long foreseen future that our species has. And so, yeah, welcome everyone. Feel free to hit the request to come up. Dazzling M, Shellfish, welcome to the space so fast, guys. And I'm gonna grab some stuff to put up top while I cook some quesadillas for Quesadilla Tuesday today. We can pretend they're tacos, though. Welcome, Shellfish. Are you there, Shellfish?
Yeah, sorry, just trying to find my earbuds. I'm good now. How's it going?
Doing well.
I see we have an inverse bird in the room.
An inverse bird. Yeah, I enjoy that. That's actually very comical. Oh, I wonder if today is the inspiration of such an adversity. But feel free to come up and tell us while I grab some stuff to put up top.
Did you just come up with a new concept, inversity?
It worked.
How's everybody today?
I am.
Hey, what's up,
Pretty
man?
good.
Welcome up. Yeah, I'm just grabbing some stuff to put up top.
Oh, yeah, no, cool. No, all good. Yeah, I kind of I tend to troll with my I'm having fun with my bird, pretty much. So usually it's a troll to kind of signal for myself, really, when I troll where the market's kind of going here and there. So it's been facing straight down for the past couple of days, and now it's just upside down. 'Cause I don't know where it's going, but it's I think it's just me just kind of messing around, just playing around with the board. Something to do because I like this PFP. I like this NFT. So
Oh, it's
just for
nostalgic.
fun. Yeah. So just messing around with it until I get bored. But I don't think I'm gonna get bored. Just keep around. But appreciate the space.
It's from before a time when time was before itself. Thank you for coming up, though.
I feel like the 143 is like a shout out to the whole it should be like for AI, right? Like 143 in text code is I love you. So like we should do like a whole like AI space because AI in Japanese is love, right? We should do AI in this space as well today.
Well, I'm definitely going to incorporate it into the conversation. There was no room in the title, though, for it today. Of course, I would have liked to have my Gen AI up there as usual, but there was only two characters left. But going to the topics that I did post up top. So, some stuff that we'll probably touch on today. Things like warp drives, some quantum teleportation, which is all of these things are very akin to we'll say the word quantum entanglement, the entanglement of particles that can possibly exist in two different places of what we think of space and time, essentially at the same time. And so think of things like warp drives, black holes, quantum teleportation, quantum communication, all of these being factors of the relative levels of possible entanglement we can mathematically calculate and understand. And Yeah, and so AI definitely being a large part of that, especially when you think of the means of data sets, the calculations of mathematical algebra that would need to be done when taking into consideration if we were able to accumulate knowledge of said particular. Think about it as a field of space, so a field and section off where you could clip a section of space and graph it, and by understanding this mathematical notion of the most likely scenario of all the particles in say said field, we could then begin to understand how we could then mathematically entangle particles of both the field we're relative to interacting with, and then say another field that maybe exists somewhere else in time and space. And so yeah, cool little thought of a conversation today. Going to be a little bit speculation and enthusiast conversation. So yeah, if anyone has any questions, feel free to just bring them in. One more video I want to grab up top. But the first thing I posted up top, which is from Quanta magazine, which is a great follow if you're not already, and they also have a YouTube channel. The simplest observation, so the sky is blue, say that, or the particle is there. Focus, focus forces us to question everything we know about the workings of the universe. And so, great little read if you guys have a couple minutes. Really goes into the notion of the double slit experiment. Is it a wave or is it a particle? And upon realization of, say, interacting with something, we could say it's a particle, right? The particle hit the sensor, and so we know that the beam of light was particles interacting. Yet, why then do, when we can scale outwards and put sensors all around it, do we also get readings of particles, what we would think of to be particles hitting it? It tells us that no, it can't be a beam of particles. It must be a wave. And so this interesting factor that makes us question everything about the reality of this matrix that we seem to exist in, at this notion of time in our existence. But turning to the other side of it, where we could use it to our advantage, the understanding of waves and fluctuations of these different types of interactions that occur and what their reactions actually are. Thinking that, well, the reaction is now different. We know that it's not just a beam of particles, but there is a wave involved. And so there will be a magnetic field that is associated with this beam of particles. And so we learn about the association of not only the particular object in which we were trying to get an answer about, but the actual surrounding, the 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 frame and reference of time around that particular segment of actions that we were thinking that we were only going to witness or observe. And I think this plays a huge role into thinking about how we could use things like linear algebra and um, the mathematical calculations that a quantum computer would be able to be paired with and do. And when it comes to these types of calculations, say calculating even very small tests that are already being done, calculating the movement of just mere atoms and being able to entangle two different states of information with the same observation the particular state is having occur. And so, this ability to have object A and object B have an entangled state between the two of them, and how do we mathematically calculate those states and distance, and of course all of this, every single wave, when you think about it, every single interaction of field. And so when you think about distance, if you're standing in front of me, there's much less measurable interference, much less magnitude of electromagnetic waves that would be in an occurrence of what would need to be measured, right? You think about, something like quantum superposition. How do you calculate the superposition of the particular particle, right? Well, we need to also take into effect all of the bending of interactions of, what we think of light, that would maybe occur over this long distance of information transfer, this entangled web, if you will have it, of the light itself, um, being entangled with the information from the previous interaction that had occurred. I've spoken a lot, though, a lot of mumbo jumbo. Go ahead,
Yeah,
Josh.
I mean, doesn't it come down to just like the physical representation of a drop of water and the ocean in its entirety, being like a particle and a wave? I don't know. I just kind of like see that clearly in my mind because, well, one for perspective, for a perspective, if you're small, that drop is like an ant. It would be massive. It wouldn't be just a drop. It'd be quite large. But to us, that drop is just a small, like, pinprick, right? But then if you throw that drop into the ocean, good luck finding that one drop again. It's completely entangled into the vast amount of other drops, which become one large unit of water. Anyway, that's
Well,
kind of how I imagine it.
and that's what I'm saying. Don't say wish you good luck, because what we're exactly attempting to do is saying we are going to know the exact, not only positioning of that one particle of water inside of that ocean of web, but we're going to also be able to calculate and associate every single interaction that it's ever had up until that moment in which we took the calculation of that particular, in this case, droplet of water, and all of the associated energies with it. So that's exactly what, in an analogistic form, when you think about something like quantum communication, right, this entangled states of information being able to transfer faster than we would think of the speed of light. Well, we are attempting to not only measure that water droplet, but we want to mathematically calculate every other water droplet it's ever interacted with up until a certain point of what we would consider time inside of space, which we all
So you're running a full history node on every particle ever.
running a
Um,
full history node on every single particle that's ever existed in that interactionally based web. Of course, that's why, when
that's
I
a
said
lot of
earlier.
data storage.
Well, see, this is why when you want to think about it, you want to think of it as fields, because you start narrowing down, and think of it also looking at it from a graph perspective. You start narrowing down what's important, what's not important very quickly, so you can say these mathematical calculations I don't really have to worry about. This is, I'm trying to direct it in this particular direction. Maybe those come into play. Maybe you do need to calculate those. It's such a wide array of interactions. But yeah, I don't think uh, any one uh, particular way would, be the only way, I thought.
Kind of fascinating to think about because I mean, I was in like the space with Ed and Matt Hamilton, and they were talking about how the data storage would, I think maybe only go. I think it was in that space. I was watching a video also. Anyway, so say you would only need data that would be retrievable within 5 years, compared to something that would be something, say an NFT that would be more accessible. So then you start thinking of a full history node for like an atom or planetary scale. Like, would it really need to know exactly every possible transaction on a galactic or planetary scale?
Yeah, I mean,
You could just
you could have an entire planet size of Earth that's just a computer. It's just a big computer in space.
It's a lot of energy being used.
I wouldn't fray away from the thought of magnitudes and greater of usage of energy that our species could accomplish, even just here on Earth, terrestrial. Um, the the thing is though, when it comes to energy usage, we think about like the way that we do energy so far for our species, very insufficient. Burning oils and and nasty chemicals and things like lead, right, that are in gasoline. Yeah, we very, very disgusting and detrimental in thought of the way that we produce our energy, maybe at the moment. But yeah, no, I mean, you know, if you got a computer the size of the Earth, there's probably a reason for it, right? So that use case probably plays much larger in part with rather than the thought of the wasted energy extent. Of course, it depends on how it's being powered. It's probably something that large is probably being powered by a nuclear reactor of some sorts the size of our core in our Earth. So, yeah. Reminds me of the Death Star, which is also a great example.
I'd probably say that the way that we've harnessed energy so far, other than corporate wanting to make a ton of money on it, has been kind of the most efficient way that we've been able to do it up until this point. We probably could have done it better. Yeah, there were inventions many years ago from Tesla and some other great minds that had ideas of us consuming energy that would have been much better for the planet. But it's just kind of what we were able to do at this point in our human history that kind of got us to where we are now. So I can imagine on other worlds it would be different. You're working with different elements, and you got to warp, um, you know, different elements into certain types of energy and all that kind of fun stuff. But we're getting there. We're slowly getting there to a better way of consuming energy in and around the universe. And that's cool. Hopefully we don't destroy ourselves in the process.
Yeah, I mean, there's definitely a huge sociological aspect to the reasoning of why things are exactly where they are. I completely agree. You know, you think about cars. I like that you brought up cars and mentioned them. The first cars that were ever produced were electric cars. They were actually ran on batteries. The Model T Ford came out though, and was able to, produce a vehicle for like 1/10 of the cost, and so killed all the electric car manufacturers right off, and they never came back since. And then of course there was very strict regulations on batteries and such technologies, like the understanding of the physics of it. There's something actually that's very recent that is able to be talked about now. So, every like 20 to 30 years, you have this like generational rollover in, it's not just the United States, it's most countries about the, classified things that become declassified. And so one of the things that recently became declassified in the last couple of years was, in the early 60s, right, and even going back to the 40s, there was mathematics and physics that was discovered and starting to be learned about that was actually classified, became classified, right? And so like programs and stuff as such got shut down in colleges, and some of the physics got locked up forever. It's really interesting when you think about from that kind of aspect, right? So there's a huge sociological aspect that gets taken into play when thinking about the progression of how fast we technologically advance. And I think probably for meaningful reasons, of course, but it's definitely something to take into consideration.
It's interesting you said that because before when you were talking about kind of particle interactions, I was thinking about you were referencing the mathematics that we have behind these kind of how these things work in the physical universe. And I was thinking about things that we haven't been able to mathematically kind of prove, and and that yet we're going to discover. Um, like how do you discover new mathematical formulas? Like that's just a concept of creativity that I guess I'm not privy to, but what a cool kind of thought process to go through, I guess.
It's very close in relation to thinking about how somebody would make a language. Like how did somebody come up with English? Actually, English is probably not the best example because it's kind of like a mess of a story. But in general, right? Like math is, in my opinion, the only language. It is the first language, and it's our representation of externality. So it's the understanding of the indifference of measurement. So us as self, and then everything else. Um, it's a yeah. So how do you really define that? I think you start with notions. You kind of pick things that exist in reality, and you draw symbols, and you say the representation of this symbol means this thing, and then you build all of this type of symmetry. And you think of math. I mean, that's math is symmetrical in that way, where you have this pathway of an equation that gets taken, and you have a sum of an answer, and they're all in relation with each other. But yeah, I mean, that's definitely way more difficult than just that. Stephen
I, I,
Wolfram would be a great person to ask for that.
yeah, I don't mean to like deviate from the topics, but just like sitting on mathematics there. So if I was, I'm in my little lair and I'm, got my chalkboard and I'm doing all my calculations. I'm probably doing it on a computer, but anyway. And I think, okay, well, I've kind of discovered something. I need to create like a new symbol or a new way of, for people to understand something like this. And I create that. How then is it accepted by the wider scientific and mathematical community? Is there a process of deliberation where they all kind of sit down and kind of, a group will say, okay, yeah, we all agree on this, so then they put it forward and it's kind of pushed into, I don't know, is there a mathematical legislation or something like that or standard across the globe?
I,
Um,
I, I,
mm,
I wouldn't say that there's necessarily a mathematical standard, but it's as simple as thinking of it as you would build a set of keys, right? And I mean key, you build the notions of the symbolic representations of what you're trying to symbolize, and then write a definition for it, right? So this means this particular aspect of reality, this means this particular aspect of this means this particular aspect of that. You build a key for it, you write whatever your mathematical equations would be using those notions, and as long as there's some sort of symmetrical representation that can be met using those equations to come out with a sum that has some sort of actionable difference in the reality that we have, that's why numbers are accepted by everyone, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, is because we all have some sort of notion of one, two. Even if you're not saying the numbers, right? Like that's the first one, that's the second one. You're saying some sort of logic in your brain to measure the difference between object one and object two. And you just have to create a pathway for that to be able to be observed. I think the most recent person to create, I don't know, I guess it was the 90s, but the most person, I guess it would have been like Isaac Newton, right? Most, I guess the largest mathematical change. Yeah. I think there were other things that, like quantum field theory and stuff like that, that were written in the 50s, and other things pertaining to physics. Yeah, it's hard to say. It's ever evolving. I would say that's probably a better way to put it.
we're totally going to end up with the question of like, did we discover it or was it kind of like always there type of philosophy?
Oh well, this is a very strong opinion that I hold. Is we never learn anything. We know everything. We are just rediscovering the answers to the questions that we hold at this moment. And so, yeah, like math, right? Would math be any different to us or from us to any other species? Well, if they exist in the same realms of understanding that we would, meaning we're able to have some sort of interaction in the first place, well then, even if their symbols and ideologies are different, the the mathematical properties of notions, the same keys of representation. I mean, we exist in the same plane, therefore there is a symmetry between those. And so, yeah, I mean, it's like math. It's like a universal concept, in my opinion. Yeah, and as you said, there there are there are physicists out there who are who are trying to create the next kind of roadmap, the next kind of piece to the puzzle, where whether it be someone like Neil Turok, which is taking something like all of what we have today of physics and then trying to create an answer to dark matter. He calls it the mirror universe. So he's trying to give an interpretation of why the universe exists the way it does. So that's like an interesting thing. You have other people who are starting a lot of people in the physics community who are starting to go much more of the spiritual route, and this Platonic understanding of this underlying metaphysical layer. We could call it, I like Michael Levine calls it the Platonic mind layer, where there is some sort of symmetrical relations to dimensional energy in which makes the whole structure of our universe and what we exist in possible. Whether you call that quantum field theory or string theory, and try and interpret it all the way down to what would be vibrating strings that make up the symmetries of everything, or we kind of take it as like a base layer and we say, okay, well, these possibilities are definitely here. How do we interact with them? I think that's probably a better approach, more digestible for the everyday person. Yeah, have all of these different theories, kind of, and maybe always this has kind of been like this, right? But all of these different kind of theories of the universe and physically how to interpret it mathematically wise, there's always indifference, and so maybe we get to a point where we have like what they call like the Einstein moment with general relativity, where everyone who takes it can't really disagree with you, and you would say, that's fact. I think there's also a lot of interesting things about Einstein's theories that have been proven wrong over time, and maybe continue to get proven wrong. Think about the Einstein-Rosen bridge, right? Um, the the notion is that you can connect these two wormholes, these two black holes, but because of Einstein's equation, the gravity of the black holes would suck you in infinitely forever. What we came to recently learn in the last year or so about more in depthly about black holes, specifically talking about the gravity and the measurements we've been able to get from the gigantic black hole. I'm going to blank on its name. I think it starts with an A. That's in the center of our galaxy, and it looks more to take. It looks like black holes might have more of a layered approach. And so when you think about like a singularity event, to the observer outside of the singularity, because of the warped gravitational speed of light, you, from the outside, might infinitely watch you approach and get closer and closer to the center of the black hole. You in the center of the black hole may just go right through the black hole. Never, and you talk to some people where they think about you get pulled into the spaghetti, or you get twisted into a gazillion particles. Well, that may still happen, but it looks like black holes might have more of a layer to them, where this gravitational density ring sits on the outside that's consuming things in, and as and the center be a and I'm probably not going to do the best for it. I can go get the YouTube video actually where this was explained. It was really interesting. But the center be um, not exactly what we thought to be this infinite gravitational well that just sucks you in, but possibly more of a pathway to the connection to another black hole, which is already mathematically possible. You think about Einstein's Rosen's bridge, right? ER equals EPR. This is also somewhat was proven to be possible and a possible fallacy at the same time just a couple of years ago. It's a video that I used to post up top all the time, where we had a small research team using Google's quantum computer that simulated two black holes in a distant galaxy, and then using quantum entanglement, sent one piece of information the size of a qubit through the black hole, and mathematically had have a probability that it came out the other side. And so, not only proving ER equals EPR to be mathematically possible and true, but the fact that we can freely move the energy from one state of entangled space to the next step really just is learning how to propel such a piece of information outside of the black hole that we had entered. And I think information points to this gravitational possibility where you could create what we might want to think of as like antimass or antimatter in some sense. Um, that's able to gravitationally disrupt what would be to suck you into the bowl of the if you want to think of it, a black hole as like a bowl, right? And so if you ever stirred a liquid around, right, you get a lot of stuff that gets stuck on the outside, and as long as the liquid is swirling on the outside, you have that gravitational force to be pulled to the sides of the bowl. But if you go directly through the bowl, you have the easiest point and chance of breaking through. You know, obviously, if you were thinking of there was a liquid on the other end of it. Um, yeah, that's actually an interesting way to think of that
You
as an
know,
analogy.
I think we won't be able to really conceptualize a lot of this stuff, Dazzling, until we have the cybernetic merger. I've kind of like thought a lot about this since we were discussing what would happen with people having the upgrade to like their visual spectrum. Right now, you know, we can only see uh, what is it, like the ultraviolet or whatever it is, but if you had the lidar and all these infrared and everything layered upon, I love you too, baby. And so if you had those different things, you would be able to conceptualize a lot of different elements that you wouldn't be able to right now, like say geometry. We can only see a cube and what is it, maybe a hypercube, but like to actually have our mind see what the next phase would be. I can't remember what the next stage from after the hypercube is. Um, Crap. Anyway, but being able to see it in merged with a supercomputer and being able to actually visualize that would be amazing. But would you be able to actually express it to somebody that's not connected in? That would be the real question. Try. That would be like trying to explain God to somebody that has no idea what God even is, right? Like taking such a huge concept and watering it down.
Yeah, so that prompted me to remember yesterday about them mentioning Elon's, I forget what it's called, but there was a gentleman talking about being technically legally blind and having the fear that there'd be an apocalypse and he wouldn't be able to get contact lenses, basically. And he's like, I want to get the surgery before we have an apocalypse. And it's a Neuralink product that they've released, and that it will enable not people just to be able to see, but also see in different spectrums as well. So I thought that was really cool. Sign me up.
I mean, we might even be able to see like the black hole differently through that type of expanded knowledge, being able to see multidimensional rather than just a four-dimensional being existing and seeing a three-dimensional space, right? Isn't that how it goes?
Beautiful.
Well, I kind of went to the like seeing through clothing, but yeah, that's just me.
So now we're going from three-dimensional beings to fourth-dimensional beings. Yeah,
No, no. We aren't we fourth dimensional beings seeing three-dimensional and existing.
so they say we call it three plus one because we're not perceiving four dimensions. We're perceiving three dimensions plus one being time. Fourth dimensional space is a whole different ballgame. You know, you ever seen the cube where it like the cube has the connection where it looks like it should just be a really big cube that's connected, and your brain is just like doesn't make any sense how that thing is connected right now, but it's a cube. That's four-dimensional space. And so when you think about our creature, us as creatures, it's like your brain can't even do it, right? Like try and think of a fourth-dimensional cube. You can put yourself inside the cube and you start looking around it, but it's like, what is this thing? And so I don't even know what a fourth dimensional creature would look like. Probably would not look like anything normal to us, at least in the third dimension.
Well, maybe it has to do with like, I mean, have you seen that meme of like what an angel would actually look like according to the
Yeah.
AI, where it's like the eyeball with like a
Well,
million wings and stuff like that? So if we were actually existing in that realm or had our visual spectrum expanded, would we be able to conceptualize it the way that the AI is seeing it compared to what like, you know, we just picture it as a human with like, you know, two wings like a bird, but the way it was kind of characterizing it in the prompts or however it came to that conclusion, it may be very very rational in another dimension, right?
It's just a question that I can't answer because you're like, what does this look like when we're in the fourth
No,
dimension?
no, no,
What
no.
did
I no. You literally said when we started, this is all speculative and just fun today. I'm not asking for the answers.
I'm not saying it wasn't. I'm just saying it's like,
Definitely sure. Why don't you tell me why God is not visible and there's angels with like multiple wings and a giant eyeball?
well, see, like I liked that though. I liked that interpretation actually, that picture because it was really greatly analogist. It was. No, I'm just gonna just not say it, but it was a great. It was a great interpretation of like something that's written down to being like, no, this is like what you described, just so you know that, and like yeah, like right, trying to think about what we're actually talking about. I think it's important because you think of something in fourth dimensionally wise, it's really hard for us to talk about just because we can't really interpret it too well. But back to the light thing, because I thought that was interesting. So we see the visible light spectrum, and the reason that we call it the visible light spectrum is it's essentially the frequencies that we see in between of and of themselves, which is colors. Right, and so we see as you guys see colors, that's the light spectrums that we're able to pick up, which we interpret and then of course make a visual context of the reality around us. Ultraviolet, though, if we were able to see an ultraviolet, we'd be much closer to in tune to how like a cat has eyes, and so even when it got dark out, you'd still be able to see the surroundings pretty well around you, and of course all of these other different cool interactions of frequency that are of course always around us anyway that I'd be able to see. When thinking about it in space travel, I don't know if we necessarily need to incorporate it into our physical beings. I mean, I think it would be cool having all of the visible spectrums of visible, having all of the spectrums of light visible. So not only just what we have today is our visible light spectrum, but ultraviolet and X-ray. And then the real question comes down to the depth of measurement. And so when you think about like how what you're viewing, right? You're viewing a measurement of interaction. So between you and the wall that you're looking at, there is an assortment of interactions that are occurring, photons bouncing off of photons that eventually land inside of your eye socket that bounce around, and then you pick that up as the signal around you. I think it's something like what's it, like 200 nanometers a second or something like that. No, sorry, 200 yeah, 200 nanoseconds of yeah, something. Sorry, I'm just thinking of something else. But and so figure, does it make sense to incorporate that into you? Because is it going to be, a spectrum of, if we were in outer space thinking about like you viewing a black hole, like are you going to get close enough to it where it really matters if you have these different spectrums of understanding? Like how is it going to benefit you? But definitely on a ship. I think there's no question about it that we need to be picking up all of the spectrums of waves possible on a ship, so we can also calculate and get ready for if there's a large EMP that's flowing through the universe between one star system and the next. We might want to be able to pick up on some of the information from an entangled state prior to interacting with that electromagnetic pulse so that we can direct ourselves to go whichever way we need to avoid said collision. I think that's cool. Yeah, and anybody in the audience, please feel free to hit the request and come up if you guys would like. We're just having like a little enthusiast speculation conversation. We're talking about quantum entanglement and possibly information moving faster than the speed of light. We referenced some stuff earlier and have some posts above up top. But yeah, anybody that wants to come up and change the subject or ask anything that we've talked about so far, please feel free.
Okay, how about this? So information faster than the speed of light, and we have Noah. I cannot remember his last name. Dazzling, help me out. The um, Neuralink patient zero. Um, anyway, so he is using his thoughts to prompt on the computer, And so how how fast is his telepathy range? And I guess would it eventually be something that you could utilize between here and say Mars, or just like would it be just Earthbound?
Oh, so you're talking about the latency. So the latency. Man, my brain. Why am I doing that? The latency for Noah. What was it? I think it was something like. It was very short. It's very short. I can't imagine it's more than a couple seconds right now. It almost very similar to how fast we move our mouse. Think about the latency between your mouse and moving it on a screen. So it's pretty quick. Should be way quicker though, and I think in the next following models, actually that was two of the things that were talked about that he had requested to be upgraded was the battery, so the ability to charge the device when he's using it. So say you could have a portable battery that have an extra one that you could plug in, so when you're using the one that's in and it dies, his excuse was so I don't have to listen to my mom or my girlfriend, right, or something. So that, and then the latency, picking up that movement speed on the screen.
Is that speculative latency? Because I know that they've been very quiet about what goes on with Neuralink, and they kind of leak a lot of stuff out. They're keeping us all on the edge with it. With
Yeah,
everything they're doing over there.
they publicly, so Elon and four of the main devs sat down and they did for like a 45-minute YouTube video. It's on YouTube and it's on X, of course. But yeah, I mean, um, I should say it was an X video. Now it's on YouTube, actually. Sorry. But yeah, they did a nice little clip where they talked about some of the advancements and things that have been going on. Gave a little status report on it. Yeah, was that last week or 2 weeks? 2 weeks ago, I think
It
actually.
was 2 weeks ago.
Yeah, I do remember seeing something around. I didn't watch it though, so thank you.
Okay, so is he only able to manipulate the stuff that's on his screen or within like a 6 foot radius of his computer? Like if he sat down and meditated, would he be able to infiltrate like Wi-Fi and like manipulate the screens at say Neuralink, like at the headquarters at like how do you restrict that connection if it's telepathic and wireless?
It's Bluetooth. It's Bluetooth.
Okay, so again, so how would he, like,
You ever
how would
hook
he
up?
not go ahead.
Have you recently hooked up a Bluetooth device? So usually it like sends you a thing and it's like your code is like 645-777. Is this your code that you're seeing? And you're like yes, and then it pairs the device together. So there is an encryption involved for sure.
Sure, I'll just sign up and you'll go experience it for yourself, right?
What'd you say?
Oh, I just told
He's
Shell to
telling me to get
go.
on the list.
Yeah, go get on the
Yeah,
list
yeah.
and sign
Yeah,
up.
yeah, it's not like somebody's like walking over and like they have open Bluetooth. Well, I guess actually, if you had your Bluetooth open, you had the ability to connect with the device, which is something also, right? Because not every device is just going to be compatible. This is a specific algorithm and program that's running on a computer. So but yeah, I mean theoretically, right? Like I mean this people do this today. If you're walking around in like the grocery store or the mall and your Bluetooth is open except connections with everyone, well you're in danger because I could walk up to you and steal all of your information on your phone. I mean you're gonna instantly connect with me and our devices will be connected and so there are an associated amount of attacks that could occur from something like that. So don't do that if you guys have your Bluetooth connections on. I have my Bluetooth off always unless I'm turning on a device that I'm going to connect directly to it. And then, of course, you still have that barrier wall. Typically, it pops up before you pair a device, and it says, "Is your code 45?" Yes, and you click yes, and then it pairs with the device. And if not, no pair. Don't go around pairing your device everywhere, Shellfish.
And now you tell me.
You're gonna get ca-
I
you can
got
catch,
open ports everywhere.
you can catch a virus.
It's funny because when I'm at work, I'll connect to my Bluetooth headset, and as soon as I turn it on to try and discover the device, if I'm at someone's house, I just see like one, two, three, four, five, uh, Bluetooth devices just pop up, and there's no lock on them. I'm like, guys, come on.
Yeah, like even that, the Wi-Fi, you can, so like with me, turn your SSID off, right? If I walk around your house or your neighborhood and I turn on, search for local Wi-Fi connections, I'm going to be able to see all. And of course, if you have a password set, for the most part, WPA.3, you'll probably be fine. Even an average person, someone's going to break into even WPA, which is a little older. But um, you can turn off if you go into your router settings. You can turn off typically the discoverable, and so you're not discoverable. And if you go to connect your computer Wi-Fi, you could just do troubleshoot setup connection manually, and you type in the SSID, and you type in your routing number, and boom, you're connected to your Wi-Fi. So at least
I
it'll
can
pop and you can sign in.
I I can guarantee that most people that set up routers in their house have absolutely no idea how to do any of that. Unfortunately,
That is for sure. Definitely possible though. All of these things are small security parts. The most important thing you could do is your accounts rotate passwords. It's really all you have to do, and you'll never be hacked.
I think it might be something to point out as well that if you are, because I'm in the construction industry, I go into a lot of different houses, and you can just go to the back of a Wi-Fi router and just grab the passcode, right? And then park out the front of their house at night, and off you go, right? So there are a lot of crime syndicates and stuff that will go around and do this kind of thing. So yeah, it's always important to kind of stay on top of the security of your Wi-Fi devices. Because yeah, you don't want to get hacked, right?
That's right. That is the thing. People just use the code that comes on the back of the router, huh?
Well, I'm saying it because I know a builder that a job that they did that it happened to. So because back in the day, well, still sometimes today, you leave some things on a job site, and the kids will kids will rock up, and it'll just be some kid that's working with the plasterers, right? And he'll come in with a crew, and then he scopes the joint out, goes, oh yep, yep, got all this, and then he'll come back with all his mates later on. And that was one thing that had happened, and they actually were able to hack into their bank accounts and steal some funds. So yeah, got to be very very careful.
It's pretty thought out, actually.
100%. That's what we're thinking.
But yeah, that shit. It's always kind of typically this way, right? I mean, anybody who considers doing a malicious act to benefit themselves, it's like you try and prey on the what you would think would be the weakest prey, the easiest prey, which is typically someone who's elderly because they don't have the advanced knowledge on this stuff. So yeah, it's sad. But anyway, back to I never even got the videos that I was gonna post up top today. If you guys want, feel free to jump back in real quick. I'm gonna go grab this. Oh, anybody who likes detailed videos, let me just say that this was probably one of my favorite detailed videos I've ever seen on the making of CPUs. And so, thinking about GPUs and CPUs and quantum entanglement, this is one of the advantages when thinking about being able to measure. And so back to like a quantum computer, because quantum computers are very specific task driven machines. And so thinking about linear algebra equations that could be used when thinking about making a microchip, and all of the different composition of layers and transistors from that nanometer scale. Of course, in Intel, as much as they're having so many issues right now, sad to see, they've broken that 2 nanometer spot position. They did that 2 years ago already, right? They're all the way down to 1.6 nanometer per transistor. An equation, the magnitude of computational possibilities between the measurement of these fields of transistors that are interacting through these electromagnetic waves, these photons that are being bounced around. The study of quantum entanglement, adding into the thought of photonics, which is the study of the array of light, how energy or light moves, whether in a particular microchip or there's many. Everything is light, and so it's really the study of the array of these fields. The way that even the photons are bouncing around inside of a microchip. The There was actually a recent Nobel Prize, and I'm not speaking about the attosecond measurement time, where there were three scientists who have broken the measurement of the Yapto scale and all the way went down to being able to measure the movement of photons inside of an atom on the attosecond scale. That's how quickly, of course, these energetic forces are moving to be able to be measured. And thinking of something like a quantum dot. So having the capability of being able to not only measure a particular state, but follow its interactions around in a particular system where we can measure all of the other interactions that are actually taking place from the reaction of that interaction, we're will, in my opinion, are going to be able to turn up the scale in the way that transistors and computation is done inside of microchips in the next 5 to 10 years to magnitudes past what we already have it today. We have been seeing this. You look at the last 5 years, going from DDR4 to DDR5 RAM in residential households, and GPUs, going back from the Nvidia Nvidia's 980s to where we're at with the A100s and the H100s today. It's it's hundreds of percent in magnitude of increase. And I think that potential is actually going to just keep jumping, where we'll get thousands of percent increase, and then thousands of percent increase, and tens of thousands of percent increase. It's not linear at all. It's magnitudes of increase that I think are going to come out, and we're seeing that from a generational perspective already. So, yeah, really excited the advantages of quantum computers and what they're going to bring from a scaling perspective when it comes to the measurement of computational systems, chip making and manufacturing in particular, these simulated operations that can be done on a computational system before we manufacture them, so that we have the best chance of execution. And yeah, please feel free to jump in now. Either of you guys, Shellfish or Dazzling. I'm going to take a break for a second.
Oh, I was lucky enough to watch that video you're referring, and I thought it was pretty mind blowing. Did not realize the intricacies of how chips were made, and the fact that like humans are pretty much out of the mix. It's like the robots are sitting there making them, and just the layers upon layers upon layers to make those chips. It was freaking awesome. Yeah, and, you kinda, like, realize why it costs so much money to have them after watching all the steps. Yeah.
Yeah, I mean, think of just an ADL machine, right? And of course, anyone in the space, ADL meaning atomic deposition layering. I mean, even that process could be done something like 36,000 times for a microchip to get made. The exchange of a very thin layered of gas paired with an ammonia, and then a vacuum chamber. Inside of a vacuum chamber, which then, of course, has an exit of when they pull all of the vacuum everything out, creating this very very thin layer of the next layers of the microchip. It's really cool. So many processes, though. Of course, that go into each one of those, and not every plant being the same. That's why some microchips are made differently than others. So to say, no microchip is equal to all other microchips or manufacture.
I remember going down the CPU route what it was quite a while ago, and basically, it just kind of seems like they're, just very small miniature circuit boards in a way. But wasn't it because the smaller the pathways are, the easier they were to control, or maybe it had something to do with temperature as well. The temperature was more easily controllable at that kind of scale as well. From memory, though, so correct me if I'm wrong.
Yeah, so it's a combination of two things. But you're basically yes, right? And so larger the chip, the more electrons that need to be pushed through it. The more interactions means higher heat, right? And the more heat also means more electricity, which also could pertain to higher voltages, which is seem to be very detrimental to a lot of CPU chips. Is they need to remain cool and in specific voltage ranges. But yeah, I like the way you described it. Right, they're like big CPU boards, and then of course there are specific cutouts of layouts of this big CPU board with all these transistors into it, and then um, whatever the computational side of it is then of course programmed into it before it leaves the Intel facility or whichever CPU facility you're talking about. It's so interesting. It is very interesting.
Dude,
Microchips
can you
process.
try imagine someone trying to conceptualize that concept 200, 300 years ago even. It's just unfathomable. It's crazy.
To them it would be magic, right? I mean, you know, advanced technology is indistinguishable from magic. So I don't expect that they would say anything else other than that's you got a magic boomstick there. Um, you brought up the one interesting thing though, right? Because this is actually an issue that Intel is having right now on their 13th and 14th generation CPUs. They had a huge drop in the stock market. Of course, I know the whole market dropped the other day, but people were talking about Intel, right, going under. I personally don't think they're going to have anything to go under on. I think they'll probably be okay personally, and they'll rebound with their. I don't know why it didn't let me bring you up there, Cookie. They'll rebound with their next generation of chips that I think that'll come out, which they're trying to target more of like the possibility of having AI integrated into it, whatever that means for them. Um, it is definitely a little comical them being so steadfast and then running into the error that they did. So they moved so quickly that a large portion of their 13th and 14th generation CPUs apparently have an oxidation issue. The only reason they would have an oxidation issue is they rushed this process of chip making and did not let some of the layers uh, settle correctly. And so, because of it, it created a oxidation issue that if you go over a certain voltage on it, pretty much burns your chip out. And so, as you can imagine, for even businesses, right? Like there's one case that kept get brought up, which is like a large Minecraft. I don't know if they're a studio or it's just like a company that's running a whole bunch of Minecraft servers. But they bought a whole bunch of Intel CPUs right when the 13th gen came out, and they are burnt pretty bad because they are just rejecting the RMAs. And now I think Intel has finally came out and said they're going to extend the warranty for like 2 or 3 years for anybody who purchased the 13th and 14th generation, try and make up for it. And if you get rejected by like every YouTuber is pretty upset with them. They're like, if you get rejected by our return process, just try and start another return. And if you get ejected again, just try and start it again. So it's basically like just wait until you finally get someone that's just like tired of hearing other people, and they'll finally let you return it.
That's so interesting. I wonder if, I mean, well, Apple like to keep everything in-house anyway, but I wonder if Apple kind of had foreseen or anticipated that happening, or kind of had some inside information as to why they moved away from using Intel chips. That's very interesting indeed.
Yeah, that's right. They're gonna and I mean Apple has the has their M2 architecture and design. So M series you could call it, right? Because they have M2 and M3. Cookie, welcome up, man.
How you doing, guys? Got a question regarding you were talking about this parabolic growth in the way that chips are advancing, how long do you feel until current cryptography standards are rendered obsolete? Just because people have the ability to crack them almost instantaneously.
Okay, so this is really interesting. So, as much as we might get, and even I'm talking hundreds of thousands of percent increase in magnitude to conventional computation, how we have it today, it still might take a. You take a supercomputer, right? Right. We have two supercomputers owned, operated by the Department of Energy. One of them being the fastest supercomputer in the second fastest supercomputer in the world, breaking that 1.2 exaflop scale, for the amount of transactions that could occur on a transistor-based silicon microchip. Um, Even then, it's going to take millions of years to break encryption. So I don't think that's a necessarily issue when it comes to conventional computation. And there are also plenty of different methodologies that if we needed to, if computation was increasing that dramatically, right, we'd probably also see it paired with other increases. Because if you have an increase in computation, but you don't have an increase in storage ability to facilitate that capacity of computation that's going on, this is why we see the technology has rolled out so slowly, because everything kind of had to grow together. See, if you have a tremendous amount of computation not and don't have the ability to store it, well, it's pretty much useless, right? Like, what are you doing? Um, and so it's um, thinking about if we have a tremendous amount of computation altogether, storage capacities, talking about chips or GPUs and CPUs, even RAM, which DDR5, right, is already more advanced than what we see or the CPUs are even able to handle. I mean, DDR5 is just starting to become popular. It's already been out for like 3 or 4 years. It's a much higher megahertz of frequency than DDR4 was. But there are a ton of chips, like you're talking like anything earlier than the 12th generation CPUs from Intel can't even run with something like a DDR5 RAM. There's no the DDR5 is running at such a high megahertz in frequency that it can't communicate correctly with the CPUs. And so like everything kind of advances, and I probably said that 3 times now. Everything advances kind of together. But then we'd also be able to increase the way that we do algorithms. So today, think about blockchain and encryption. Well, everything is very lean, right? To the leanest capability we need it to be. If computation increased, of course, with cost being as they are today, even possibly, hopefully, going down in cost because computation becomes so easily accessible. The method, I think, also to the way that you can encrypt things also become easier, right? Things like think about like shards and multi signatures and different ways that your seed phrases could be stored on chain, off chain, in relation to proving the interaction that could then say associate something with a multi signature that would be on chain. I think encryption is not something that I am too worried about. Now, when you think about quantum computers, yeah, it could already be done today. But you don't, malicious actors are those who would benefit, right, from, say, having a quantum computer that would be able to do such a thing. Well, there has to be a reason to do it, right? And so this is why we, in my opinion, will really only see like governments and large universities and very large commercial businesses being the ones that have quantum computers, just like as we see it today. So, photonics, state solid chips being things that the study of the way that we do microchips today that will increase conventional computation by magnitudes higher, but it doesn't necessarily need to compute over to breaking encryptions. I think we just make encryptions longer. We make encryptions stored differently. There's different methodologies. We can create Merkle trees for encryption. There's so many different methodologies that as computation increases that will be fine in that regard. I think the more important thing with encryption is keeping a level standard between the species rather than bridging off and having your encryption standard and my encryption standard, and we can't communicate anymore because we have two different standards of the way of doing messaging. Yeah. What are your thoughts?
I was going to say to Cookie that if you're worried about your XRPL assets. Just don't do any outgoing transactions in the account, and it will be quantum proof, basically. But it'll also be gains proof as well. You won't see any gains because you just have to look at it in your wallet.
It's actually it's a process I actually already adopt on multiple chains. I operate cold hot wallets, so I have MetaMask, Trust wallets, all sorts of like web-based wallets that like only act as send to wallets. They'll only receive assets. They'll never interact with any protocols. Just generate the address, and then I send assets to them. At the moment I send an asset away from that wallet, I'll scrub the wallet and start a new one. Just it adds layers of complexity to trying to hack it.
Yeah, and I like to say there's. Oh, sorry, go ahead, Cookie. I thought you were done.
No, you're good.
Yeah, I like to say there's nothing quantum quantum proof, but quantum resistant totally. And even on the XRP ledger today, even if you do a transaction, you can actually generate a new seed phrase, secret phrase. Sorry, secret phrase. And so, after every transaction, you just gotta use an application, of course, that gives you the capability to do so. Zum does, so does XRPL Toolkit, and so you would just have to generate a new secret phrase for that wallet, make it more quantum resistant. Same thing, you could do that on Bitcoin too. I'm pretty sure, actually.
Yeah, the multi-sig feature on XRPL is fantastic. I've got a couple of wallets where I've got master key disabled, and I've got multiple signers on my multi-sig as well. So yeah, there's definitely layers of protection you can build in.
Exactly.
Yeah, and then you get like an airdrop, and it goes up, and you go, damn it, I want to take that out and liquidate it. So you got to do it again.
This was a great conversation so far. If anybody has any last minute thoughts or like a last minute thing you'd like to bring up, I mean, please feel free to bring it up. Hit the request if you guys want to come up. But I think we'll wind down and close up in a minute or two.
I think I was I want to say earlier that when I joined the call, I was on a walk, and the sun hadn't quite come up yet, and I was kind of looking up because it was a very clear sky, and there was an abnormal amount of satellites roaming around up there, and I just kind of, because it's been fairly, because obviously we're coming out of winter now, but it's been fairly overcast and pretty crappy weather for the last month or two, and I haven't seen it, the sky. That clear in a while. And I just noticed, yeah, there are a lot of satellites out there, and Charlotte made me think of, you kind of saying like, what are they sending? What are they sending up there with these launches that they're doing, time and time again at SpaceX? And I mean, like the Falcon 9s are going off, left, right, and center these days. So, they're sending a lot of stuff out there, and covering those skies. And I just thought that was an interesting observation. So. I remember when I was a little boy, I'd look at the sky, and I tried so hard to find a satellite, and it would take me such a long time to do so. And then, yeah, it's just that you look up for 2 seconds, and you'll spot one these days. I just think it's fascinating how far we've come.
And soon we'll have the artificial ring. So as it circles the Earth, we'll have to put some sort of transparent camera system in it, so that the outside observable part of the ring will still relay a picture of stars back into the Earth, terrestrial wise. Sorry, somebody was unmuted there though. Please go ahead, Shamish.
It was me. I was just thinking about making my reservations on the Lunar Hilton. Now that you said that, I'm like, I wonder how far out they're gonna they're gonna start taking reservations.
You had to bring that name out there, huh? Man, can we leave
I how
the?
about Four Seasons? I don't know, the Breakers.
I don't know. That probably will be how it will be, though. Just that's how it goes. But the name brands more than welcome to leave the name brands behind.
It was actually, I won't say it again, but it actually went really well together. I'm not gonna lie. It had a good ring to it.
We could do like
It
Kirkland
definitely did.
brand, or like you want to just be generic hotel, Gen Z hotel.
First Moon Hotel. That'll probably be the best name to put. Actually, you know what? Better question. When when there are civilian inhabitants on the moon, will it still be called the moon, or are they going to change the name of it? Because if you know anything about our species, we love naming things. And the moon is the moon because, well, how many people get to interact with the moon? Be like, this is that thing that I like. So I think a lot of people on the moon you get different nostalgic names that come from that. So I think that'll be interesting to see. Of course, if we get to see that.
I can already see everyone coming together in the town halls of the future and debating whether they're going to change the name or not. Oh, that's going to be fun. I hope I'm around for it.
You definitely in the segment of the first season of Moon Inhabitants, we'll the first thing we're gonna do is break ties off with the Federation of the Earth, and we'll have to be the Moon Solos.
Oh my God, are we switching sides? No more alliance.
Hilarious. And yeah, so this has been a really fun space though. If like I said, if anybody has any questions about anything we talked about today, hit the request, come on up real quick. Cookie, if you have any last thoughts, they're dazzling. Please feel free, guys. If not, we will be back tomorrow at 4 p.m. Eastern Standard Time. Dazzling, Cookie, anything from you guys?
I'm good, man. That was awesome. Thank you very much.
Excellent, excellent. Well, I hope everyone has a great rest of the night. Like I said, we'll be back tomorrow as long as work permits it, 4 p.m. Eastern Standard Time. And this was it was a really fun conversation. So I really thank you guys, and I hope everyone has a great rest of the night. Love you guys. See you tomorrow.